All right, this is part D, so the fourth video for section 4.3. And here we are. We have a couple of interesting little questions here on number 28, 29. So it says if log base x of 7 equals 9.5 and log base, that's supposed to say log base x of 2 equals 3.5. Then basically we want to evaluate log of 14 using that information. Not sure how that got that way. Let me fix it. Okay. All right. So, basically we want to see like what is the relationship, what relationship does the 7 and the 2 have to number 14? Well, I know 7 times 2 is equal to 14. So I'm trying to evaluate log base x of 14. So let's rewrite the 14 as 7 times 2. All right, so this equals log base x of 7 times 2, right? Well, then we can split that using one of our properties. We can split that into two, like a sum of 2 logs. So that would equal log base x of 7 plus log base x of 2. Okay, and then we know that from the information that was given that log base x of 7 is equal to 9.5. And we know that log base x of 2 is equal to 3.5. So we can just like substitute that in there. Okay, so this would be equal to 9.5 plus 3.5, which equals 13. So 13 is our final answer. Alrighty. Number 29 is similar. So it tells us that log base y of 5 equals 8.7 and log base y of 3 equals 2.6. And then we want to use that information to evaluate log base y of the square root of 5/3. Okay. All right. Well, first of all, I'm going to change the square root to the 1/2 power. Okay. So instead of this, we're going to write 5/3 to the power of 1/2. And then after that, let's go ahead and take the 1/2 power and move it to the front. So this will equal 1/2 times log base y of 5/3. And then we can go ahead and split that into a difference of logs. So we still have the 1/2 in the front. All right, and we need these brackets because we're now splitting this into multiple terms. So it's going to be log base y of 5 minus log base y of 3. Okay, and now we have it broken down into something that we actually have information to evaluate. All right, because we're told that log base y of 5 is equal to 8.7. So we could plug that in. We're also told that log base y of 3 is equal to 2.6, so we can plug that in. Okay, so we still have the 1/2 in the front. So 1/2 times, okay, that's going to be 8.7 minus 2.6. Okay. All right, and we're just now going to evaluate. So let's evaluate what's inside the bracket. So 8.7 minus 2.6 is equal to 6.1, right? Okay, we still have the 1/2, and that's multiplied times 6.1. So then 1/2 multiplied by 6.1. So basically 6.1 like divided by 2. Okay, so that would be 3.05. Okay. And I believe that is the final answer. All right. Okay, so now let's move on. What we're going to be doing next is basically using all of those same properties, but kind of doing them in reverse in order to compress, condense, combine multiple logs down into a single logarithm. Okay, so we are using those same properties. So we're doing these properties here, but now we're going from multiple logs and trying to express it in a single logarithm. All right, so number 30. All right, so that's going to be log of 0.01 times 1,000. 0.01 multiplied by 1,000. Okay, so that is, when you multiply that, it's equal to 10. So that's a log of 10. All right, now the base, since it's not shown, the base is understood to be 10. Okay. Excuse me. So you could cancel these out, but what are you going to be left with? You have to be left with something. Well, 10, you're left with the exponent on the 10, which is an invisible 1. Okay, so the final answer is 1. All right, number 31, we have ln of 54 minus ln of 6. All right, so we're just going to combine those together. So subtraction turns into a fraction, so that's going to be ln of 54 over 6. And we can actually reduce that fraction because 54 divided by 6 is equal to 9. All right, so that's just ln of 9 is the final answer. Okay. Number 32. The first thing I'm going to do here is turn this into an exponent. So we're moving it up here. All right. So that gives me log of a to the power of 1/2 minus log of 2. All right, and we're going to want to go ahead and change that to the square root of a. So that's the log of the square root of a minus log of 2. So now let's go ahead and combine them. It's going to be log of the square root of a over 2. Okay. So when we're doing this, we're going to want to avoid having exponents in our final answer that are fractions or negative numbers. All right, number 33. Again, I'm going to take my coefficients here and move them up and turn them back into exponents. So that would give me log base a of x to the power of 2/5 minus log base a of y to the power of 1/3. And now let's go ahead and change those into roots. Okay, so log base a of the 5th root of x squared minus log base a of the cubed root of y. And now let's go ahead and combine them. So it's log base a of, so subtraction makes a fraction, and it's going to be the 5th root of x squared over the cubed root of y. And that's my final answer. All right. All right, number 34. So in this case, the first thing I'm going to do is go ahead and distribute this 3. So it's just gonna be a coefficient for those. It can't do anything with the arguments like the x and the y. So we still have ln of 2x plus, then we have 3 times the ln of x minus 3 times the ln of y. Okie dokie. All right, now let's take that 3 and move it up to make it into an exponent. Okay. So we're still going to have ln of 2x plus, now it's going to be ln of x cubed minus ln of y cubed. Okay. Now let's go ahead and combine it all into one big fraction. And I know it's a fraction because I have a minus here. It's going to be ln of so it's going to be 2x times, because that's positive, so times x cubed all over y cubed. Okay, and then finally we can actually combine. Okay, so x times x cubed is going to make that x to the 4th. Okay, so 2x to the 4th over y cubed. All right, and that is my final answer. All right, number 35 is a fun one. Okay, Let's see here. So, we're supposed to be combining all of this. Okay. Think about what's the best way to go about this. Let's actually, in this case, let's expand first and see what we can cancel out, because I've got a base of A and I've got A's here. So some stuff's gonna like cancel out. So let's expand first, see what we can cancel out, and then at the end, put the logs that we have left back together, okay? I think that'll be the best way to go. All right, so I'll start with, okay, with this guy. All right, so that's going to be log base A of A minus log base A of square root of X. Minus, now in this case, I need to deal with the square root. All right, so log base A of parentheses ax to the power of 1/2. Okay, so let's see. So there's like an invisible exponent of 1 there. So that whole thing is going to turn into a 1. Okay. All right, and then we've got the 1/2 power here. So ultimately this will turn into 1/2 log base A of X. Okay. All right, let's move this 1/2 here. So we have minus 1/2 times the log base A of AX. Okay, and let's now go ahead and split up this one. All right, so I've got 1 minus 1/2 log base A of X minus 1/2 parentheses, and then this is going to be log base A of A plus log base A of X. And then let's go ahead and see here. So again, that's an invisible 1 there. That's going to cancel. That whole thing will turn into a 1. Okay, so I have 1 minus 1/2 log base A of X minus 1/2 times 1 plus log base A of X. Okay. Let's go ahead and distribute this 1/2 here. Okay, so I still have 1 minus 1/2 log base A of X then I have 1/2 times 1 equals 1/2, so that'll be minus 1/2, and then negative 1/2 times this, so that'll be minus 1/2 log base a of x. Okay. All right, now, basically we want to combine like terms. So 1 minus 1/2. So those are the constants. So those are like terms. So 1 minus 1/2 equals 1/2. Okay. And then, let's see, next we have negative 1/2 log base a of x minus 1/2 log base a of x. Okay, so negative 1/2 minus 1/2 is equal to negative 1. All right, but normally I wouldn't really want to write a coefficient of 1, so I'm just going to write negative log base a of x. Okay, and that is my final answer. Okay, and basically the instructions were to write it with using a single logarithm, which we did basically do. Single logarithm. Okay. I'm feeling a part E to this video coming on possibly. But let's just keep going. We can definitely finish this page. All right. Okay, this is pretty easy. Right here, this is just, you've got, logs and exponentials are inverse functions of each other. And so if you have b raised to the power of log base b of x, that's going to cancel. This is going to cancel with this, and then you're left with x, which is the argument. Okay, so pretty simple. Okay, log base t of t cancels out, and then we've got that exponent is our final answer for that, 2713. Okay. Okay, so that we actually talked about that rule earlier. This one cancels out, leaves you with whatever the exponent is, 4x minus 3. That cancels out, leaves you with that argument of x to the third power. And that is log base 10. So therefore you can cancel like that, and your answer there is negative k. All right, and that is that. And like I said, I don't think I'm going to be able to finish this in the next 10 minutes. So therefore, we're going to have a part E for section 4.3. And it will begin with number 40.